Okay, today's lesson is 11-2, arcs and chords. The first word we're going to talk about is a central angle, and the key word there is central. It's an angle that's on the center of a circle. So when you draw the angle, the vertex of it has to land right on that center. You can also have something called an arc. An arc is a piece of the circle. You can have a minor arc, which is less than 180 degrees. 180 degrees is halfway around, so a minor arc would be less than that, less than halfway around. Make it a little bit bigger. And a major arc would be more than 180 degrees. It would be halfway around and then more, bigger than 180 degrees. A semicircle is an arc that is 180 degrees. 180 degrees is halfway around, so if you start at one end of the diameter and go to the other end of the diameter, you've created a semicircle, and this semicircle is exactly 180 degrees. Adjacent arcs are arcs that are side by side. It's like they're neighbors. They are sharing one point in common. So here's a blue arc, and here's a green arc. And they're adjacent. They are side by side. And that's what adjacent means. It's like they're next door neighbors to each other. So if you want to have congruent arcs, they have to be two arcs that are the same. They're equal to each other. So arcs in the same circle that have the same measure and the same length. So here's an arc right here. And here could be another arc. These two arcs are congruent if they're exactly the same length, exactly the same measure. So you can mark them the same way that we mark anything else that's congruent, with one matching dash or two matching dashes as long as they match each other. All right, the next thing on your page is arc addition postulate. And think way back at the beginning of the year, we did angle addition postulate and we did segment addition postulate. It's just adding the two parts together. So arc addition postulate is just going to be adding two arcs together. Officially, it's the measure of an arc formed by two adjacent arcs, two side-by-side arcs, is the sum of the measures of the two arcs put together. So creating arcs again. Let's look at one like this, and let's look at one that's side by side with it. You're putting two smaller pieces together, and you're going to get a bigger arc. So suppose that this one right here was equal to 40 degrees, and suppose that this one right here is equal to 50 degrees. If you took the two arcs together, you would get a bigger arc. And it would look like this. It would start at one end, and when you put them together, it would form a bigger arc. Together, when you put the blue and the green together, you end up with the pink arc, which totals 90 degrees. Okay, so that's all arc addition postulate is. Two smaller arcs together create a bigger arc. Now here's the tricky part. These three rules here, these three theorems, they're going to sound kind of complicated at first, but really all they're saying is that when you have two things that are congruent, you can always find another two things that are congruent, that match. Okay, so for instance, if you have two congruent central angles, either in the same circle or in two angles that are the same, that are congruent, they're the same size. If you have two central angles like this one right here, and if you have, say, a red one, remember the central angle means that the angle is right on the center of the circle. If you somehow are told or are given that this angle is congruent to this angle, then the rule says that means that the chord within that angle are also congruent to each other. So this chord right here, from this end of the angle to this end of the angle, would be equal to this chord within this angle. The chord is a segment that has both endpoints on the circle. So this chord right here in blue is going to be equal to this one in red. Okay? This chord is equal to this chord. Whenever the two central angles are equal, then the chords are equal. It goes backwards. If you have two angles where these two chords are equal to each other, then you're allowed to say that the angles are equal to each other as well. All right, the second one. Congruent chords. If you have two congruent chords in a triangle somewhere. So let's say you have a congruent chord here that is congruent to one anywhere else, like right here. If you know that these two chords are congruent to each other, this one and this blue one and this red one, then the rule says whenever you have two congruent chords, you then have two congruent arcs. So think about where the endpoints of that chord is, and that's going to be the endpoints of the arc. You can draw it from this endpoint over to this endpoint here. That arc right there is going to be congruent to this arc from one endpoint of the chord to the other endpoint of the chord. So look, if you have two pieces that are congruent, like two chords, then you can find two other pieces that are congruent, like two arcs, and it goes backwards. If you ever know that these two arcs are equal to each other, then you can say that the two chords created by the same endpoints are equal to each other. So anytime you have congruent chords, you have congruent arcs and backwards as well. The last rule is that if you have any congruent arcs anywhere in your circle, congruent arcs like these, here's an arc, and here's an arc that's congruent to it. If you know that this arc right here is congruent to this arc right here, then the rule says you can find two congruent angles as well, and they would be on this center. So looking at this right here, you can take the endpoint of that arc, go to the center. Take the endpoint of this arc, go to that center. And here you have an angle. Right here. But you could find a blue one that's also congruent. Go from the endpoint of this to the center, go the endpoint from this one to the center, and you have another angle. And since they came from the same or from two congruent arcs, then you know that those central angles are equal as well, and it goes backwards. If these two central angles are equal, then you know that the two arcs are equal. And you know that the two chords drawn in here are equal. Whenever you have two congruent parts, you automatically have two more congruent parts that you can find. And the last rule that you need to know, it's really important, is this theorem. In a circle, a diameter or radius is perpendicular to a chord if and only if it bisects the chord and its arc. Okay, I hope that one of the first things you noticed was that it was the word diameter or radius. That is a really important key word because it means that you go through the center. It can either be halfway like the radius or all the way like the diameter. But it's a segment that goes all the way through. So I'm going to draw a diameter right here. This is a diameter that goes through the center. Now I want you to also think about what other keywords would have been important to include in this drawing. This diameter or radius has to be perpendicular, that means 90 degrees, right angles, perpendicular to a chord. Another chord somewhere. Chord has to start on the circle and has to end on the circle. But you can't draw one like this. It doesn't match the perpendicular part of the rule. So you have to draw a chord that is perpendicular to the original diameter that we drew. Okay, anytime this happens, anytime you have a diameter or radius that goes through a chord and is perpendicular to it, then this is if and only if it means it's true forwards and backwards, then it bisects everything, cuts everything in half. That's what bisects means. Okay, so this half of the segment is equal to this half of the segment. This blue line is cutting everything in half all the way across. You can make an arc right here. This arc right here is going to be congruent to this arc here. Okay, those two are equal because it got cut in half. This arc equals this arc. And likewise, there's another arc right here. This one gets split in half too. That blue line is just cutting every single thing in half. This arc right here, this bigger arc, is congruent to, just put 3 marks there, is congruent to this one. Just see that that blue line that was perpendicular to the chord, it cut everything in half.